Oh, okay, couldn't figure it. There's 32 questions.
No.
Why? Is this like a review?
It is.
Oh.
I'm wondering how many are on the test, because I think she said there were more than last time.
I don't like that.
I know. What's the other question that we usually have? We usually have 2 freebies.
Uh-huh.
Oh, they're there.
No, there's only one.
There's only one.
Yes.
Oh, yeah, they get right into it.
I'm already lost on the first question.
I'm reading it and I'm like, no.
On the last quiz, I got this wrong and I looked it up. So if it says chance, it's wrong. That's not the answer. So I even put that in my notes. If it says chance and it's talking about the confidence intervals, it's not right. So it's the second one. It's we are 90% confident that the true mean heart rate is between 45 and 105. I even put that here on my notes, correct?
Okay.
The 95% confidence interval. We are 90% confident that the true mean lies within the lower and upper bounds of the confidence interval. Avoid chance or probability. Because I got it wrong.
Okay.
I'll be back, guys.
Oh, I'm so tired.
I'm sorry. And that one's going to be on the test too, because that was in the study notes. It said correct interpretation of confidence intervals, and I was like, what does she mean? And then that question came up, and I was like, that's what she means.
Okay, sorry.
Okay. So I'll read it. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I put yes, because the distribution of the means of each sample is normal since the data have been determined to be normal.
I think that's right.
Because the only other requirement would be that it's a simple random sample.
Okay.
Let's see, number 4. Of the 4 types of confident intervals listed below, which one is appropriate for this experiment?
So they're independent samples, and you're looking for the difference of means, right?
I think so.
Yeah.
Mm-hmm.
So I think it's the third one.
Yeah.
Yeah.
Okay. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
So this one took me a long time, but I think I have the answer. Now I'm trying to find my notes. In my notes, I put that, okay, the higher the confidence level, the higher the margin of error. And then I put 90% will yield the narrowest. Wait, hold on. Higher? Yeah, 90% will yield the narrowest confidence interval for the same analysis. So if it's narrow, why are you coming in here? What? Okay. No. So if a higher confidence level increases the margin of error, then do we want 90%? Or no? I put 99% confidence level interval, but now I'm confused. Because my son threw off my thought process.
I'm trying to remember to the day when Justine, is that her name?
Yeah,
Justina. She said the higher the confidence interval, did she say the lower the margin of error?
No, because I wrote from her notes, and it's a higher margin.
Okay. Oh, really?
I put higher confidence level equals increasing margin of error equals confidence interval also increases.
So I'm not sure.
So then it would be 90%.
So we should put
right?
none of these answers.
So none.
Because then I put 90 will yield the narrowest confidence interval, which would then be the lowest margin of error. Right?
I think so.
My gosh, why is this so confusing?
Because we haven't thought
done
of this stuff and we
She can't do this to us. It should not be communal. What's the word?
cumulative.
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 After all of us give it a chance.
Oh man.
Baby, go in my bathroom. On the counter is a hair tie. Will you grab it for me, please? It's black. Okay.
Oh goodness.
So, should we move on?
We should move on.
Yep.
All right. Whose turn is it?
I think it's your turn.
Okay. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate. No, it's a round hair thing. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound, and upper bound. Okay, guys, I'm on a thing. I need you guys not to be in here. So the margin of error is m equals z over, or z times. No, just never mind. It goes in my hair, honey. I want to tie my hair back. M equals z times the O thingy over the square root of n. And so when I did that, z was 1.96 because it's 95%.
Mm-hmm.
Oh, so what? I can't even think of
Wasn't the
word.
margin of error something divided by 2?
No, that's later.
It's later?
Yeah, that's why we were getting confused because we were doing this other thing before.
We're screwed.
I could have nailed this test.
Hey, boys, close the door, please.
Oh my gosh. Okay, so
Please. Although, you know what? Well, okay, so for this kind of thing, I'm not even going to say no because I don't know for sure. But what I have is that the margin of error equals z and then times the standard deviation over the square root of n.
Uh-huh.
If you do that, the z is 1.96 and then it's 2 times 2 over the square root of 4, which equals 1.96. But, and I know 1.96 is the right answer for how you get the confidence interval. So I do believe it's right because you have to enter it into the confidence interval formula, which is the same thing as the margin of error, except for you plus or minus the X bar.
why is there 2 different formulas for margin of error?
I don't know, but that's the thing. There's actually a whole bunch of them. There's different ones for the first 3 types of tests. And that's why we were getting confused later on when all of a sudden it wasn't working.
She can't do this. They can't do this to me. Like,
but I'm like 90% sure that, oh my gosh, can you guys not come in anymore? Thank you.
I'm sorry. I'm trying to do everything for everyone right now.
Okay, thank you. I'm sorry. It's like the second the door closes. 90% this is right because the confidence interval formula, I have all the notes in the earlier stages say that then you take that out and that's the margin of error. But I don't want to lead you guys wrong because I led you guys wrong on the other margin of errors.
I'm just like, how do you know which one to use? Like,
I don't know.
That's my question. Like,
That's a very good question.
I just,
I wish it was all multiple choice.
I know.
Amen.
Seriously.
Because I do see those formulas, but I do understand your question, Stacy, that like I would have never known. Well, I kind of would have, but I don't know.
So the ANOVA, you're not going to use that. You're going to use the
Yeah.
upper bound minus the lower bound divided by 2. And I think even the 2 sample T procedures, we did it that way. I don't know.
Okay. So M equals, what is it? What is the formula?
So for the 95%, it's 1.96.
Uh-huh.
And then it's times the standard deviation, which is 2, over the square root of 4, the square root of n.
Where did you get 4 from?
If you look up in the thing, it says that they took 4 drive shafts made at the factory.
Oh, wow.
But it's written, it's not.
That's stupid.
Yeah, they didn't put the number. So you're thinking it's the 1.96.
I am. But I have
Okay.
not turned it in and I have not checked it.
Well, if that formula is correct, then that should be the answer. But I think I remember when you said the 1.96, like as I wrote it out, that sounds really familiar.
Yeah, because they gave us those 3. They gave us the 90, the 95, and the
Yeah.
99.
Yeah.
And so
Mhm.
if you input it in for the next one, for input the lower bound and the upper bound, the formula is x bar minus that same formula,
Mhm.
and then x bar plus that same formula.
Oh, right. Yep.
Mhm.
And that's how you get those numbers. And on the on the homework thingy that we were supposed to do to prep for this,
Uh-huh.
those answers were the answers on the multiple choice. They came up and they were right.
Okay. So for the lower, did you get 998.04?
I put 040.
Okay, yeah. So I was like, it says 3 decimals, so
Wait, you guys got 0 for the lower?
So 998.040.
oh, I'm glad we're doing this. I forgot all of this.
I'm telling you. I was sitting there doing this stuff and I'm like, this is just not. I don't understand why we have to do all of it together. We already learned the other stuff. Obviously, we don't remember it, but
And then so the next one is 1001.960.
yeah, that's what I come up with.
Are you ready for 9?
Mhm.
Yeah.
To assess the accuracy of a laboratory scale, the standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation is 0.01 grams. How large should n be so that a 95% confidence interval for u has a margin error of plus or minus 0.0001? Oh, I know there's a formula for this.
Yeah, so the formula is n equals z times the standard deviation over m and then you square that whole thing.
Heavenly Father, to help cure me, Dad, and Mom of all our ills, and to prevent putting down from getting them, and then from regaining them. Please help us have a good night's rest tonight, that there will be no more pain for me or for any of my friends.
Wait, don't do that. I'm gonna fall on you. Uh-oh, I'm dizzy. I know I'm not dehydrated.
You close that, thank you.
Did you get a super large number?
I got 38,416.
That's what I got too. I did it like 6 times because I'm like, that is like a very large number.
But that is also a number that is listed as one of the answers on the multiple choice.
Okay.
So
it's a good possibility it's right.
And there are pretty big answers on that, so I felt pretty good about it.
Okay. I'm like, yeah, that's what took me so long because I kept redoing it. I'm like, it can't be right.
What did you guys put for M?
The 0 for M 0.0001.
Okay, that's what I did, but
don't forget to do the I always forget. Don't forget to square it. That's what you say.
Yeah.
That's what I did, but I might be putting it in my phone like wrong, like I always do.
And the Z is the 1.96.
Yeah. And then I don't know. Oh wait. Okay, now I got it. I just had to put like certain things in parentheses.
All right.
Okay.
The next one. The mean area U of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternate hypothesis HO and HA for U are
Maybe the last one.
Yeah.
Okay, so this next question they asked differently than they did in the quiz before the review. And so the one in the textbook I couldn't understand and I didn't know how to answer it. But this one I feel like I do know how to answer it. So I'm still curious what the answer from the textbook one is. But okay, question 11. In the statistical test of hypotheses, we say we reject the null hypothesis with the level of significance alpha if p-value is less than a.
Yeah.
Mm-hmm.
But the one in the review says, in the statistical test of hypotheses, we say the test result is statistically significant at the level of significance if, and then it says a equals 0.05, the p-value is less than a is small, or the p-value is larger than a.
I have no idea.
Yeah, I don't remember them answering that or talking about it being statistically significant. Is it statistically significant if it's high, so we reject it? Maybe?
I always get those things wrong.
I know, those are like the worst questions they can ask me.
I'm glad on this quiz it's asking a more simple question, but
Yeah, but then the test is going to be super hard.
right, the test is going to be the review type question.
Yeah. Is ready to move on?
Yeah.
Okay. A group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question?
So it's saying that the sample variances are nearly equal. It's normal, whatever, normal distribution. So it's one of the last two.
The thing that's throwing me off is because it's bell-shaped.
I wondered
Yeah.
that too.
And so that's where I'm confused. That could be really minor. It could be.
My original answer that I put was that they had a total number of 60 GPAs in all, so they could apply the central limit theorem, but that isn't something that they've really talked about so much. But yeah, because it's always right skewed for the
Yeah.
F distribution.
And on the third one, it talks about like the sample variances.
But we do know that the variances are nearly equal, and that's important. Yeah, I have no idea. I have a big question mark by this one.
I know. It's just.
Because it's got to be yes. I mean, they've got it that it's normal and that the variances are equal. So the answer's got to be yes, right? Oh, except for how many apartment buildings did they use? Because you use the ANOVA for.
They have 4.
Oh, okay. So yeah.
Mm-hmm.
So it's still yeah. I think it's the third one, even though I originally thought it was the fourth one. Well, I don't know. I don't know. Because the distribution is always right skewed, but is that the distribution of like the end of it all, or does that have to be the distribution of the samples they collected?
Oh yeah, I get what you're saying.
I don't
But
like this question.
on her chart, F is under sampling distribution. And it says it's always right skewed. I don't know. My original thought was the lower one.
Mm-hmm.
I don't have a clue on this one.
But I agree, the bell shape is getting me too.
Yeah, like, and so I'm just like. What were the requirements for an ANOVA hypothesis test again?
All populations are normal. You have independent SRSs, so simple random samples, and the variances are equal.
I'm gonna go with the third one.
Every time I decide to go with one, I'm like, nope, it's got to be the other.
Yeah.
Because I was leaning toward the third one, and then I'm leaning toward the fourth one, and should we just put the third one?
I'm game.
You can, you know what? Everyone put whichever one you want.
And it's gonna be like no.
I know, it's totally gonna be no, and we just sat here and
Okay, can you tell me one more time
the rules?
the requirements again?
Yeah, so they have to be independent, so not dependent, SRSs. All populations are normal on the QQ plots, and the variances are equal.
So it doesn't tell us if, wait, does it tell us if it's normal?
Yeah, it says that the QQ, where does it say it? I know it said it somewhere. The data for each apartment building are, oh no, maybe it doesn't.
I don't think we have enough information. Because it doesn't tell us if it's normal. Well, the only thing is, like, it could be normal distributed because of the 60 of the sample, but then that's where I'm confused too still. Because it doesn't say about the information, the data being normally distributed.
But is that
Or,
what bell-shaped with no outliers means, though?
I don't know. Because I've never heard it say with no outliers, so I'm not really sure what that means.
The outliers are when they're like really far away from the others. That was something from
Okay.
the very, very, very beginning. But gosh, I don't know. I really don't. I keep going back and forth between those.
Yeah. Okay, we can all put a different answer, and then we'll see who got it right. Because I don't know. Like,
I'm like, yes, but I just don't know which one to put. Yeah, just put whichever one you feel good with. And I feel like both of those two are right. But there's a possibility that the third one could be wrong.
I would see personally. I would lean either with they don't have enough information, or I would lean with the fourth one
Oh, I love my children.
because that would imply that the information is normally distributed because it's a large sample number.
Okay, well, now your hair's really clean. Guys, I am on the thing. Get out. Go.
Okay, I made my selection.
Yeah, I made one. Let's go.
Okay.
We'll see.
All right. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has
Information.
Committed a type 1 error?
I don't even remember what they meant. Oh my gosh.
The type 1 and type 2 confused me, but
Type 1 is where you reject the null hypothesis, but it's really true.
okay, so
Do you guys think it's the one, or do you think there's something else?
I'm trying to. Okay, yeah, so I had to reread it. Yeah, I think it's one.
We'll go with that.
All right, question 14. If the level of significance, alpha, is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? And in my notes, I put that they are inversely related. So if the type 2 error goes down, the other one goes up, the probability of committing one. So it would be the first one.
Okay.
Okay.
All right. 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams U and a known standard deviation of 0.17. The brand advertises that the mean nicotine content in of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. O equals U equals 1.5, and the alternative hypothesis is U is greater than 1.5. At the level, at the 0.05 level of significance, you conclude that you should.
So we have to do the z equals x bar minus mu over standard deviation divided by the square root of n.
It was x bar minus
the mu, which would be 1.5.
Okay.
Hi, Scott. Hello. And then once you get the z-score, you have to put it into the normal probability applet.
Why? I didn't open that up.
to get the p-value.
I don't know if I figured this out right.
So what do you, so for Z I got 1.765,
Okay, yeah, that's what I got.
and then you shade everything to the right of that right line, and you
Alright,
put
hold
your
on.
Z.
I'm picking up your background.
Hold on, it might be mine.
I was gonna say, I have a little bit in my background, but I hear someone else's too.
Okay.
So shade the right side and put your Z,
Okay.
and then whatever your area is your p-value.
So did you get 0.039?
Yeah.
Okay.
Now we're all assuming that I'm doing this correctly. So if you guys know a different way.
It sounds right. I remember doing stuff like that.
That's the thing. I'm like, I remember doing these things, but
So P is lower than, right? Because it's,
yeah. So we have to let HO go.
so we reject option 4 or D or whatever.
Yeah.
Okay. Oh,
Is it my turn?
I don't know.
Sure.
Go ahead.
Okay. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure?
They're independent samples, right?
Yeah. Because they're from like male students and female students.
And
Two
they're
different-
not based on each other. It's not like a husband, so then you have to do their wife. It's just random.
Uh-huh.
So
Independent samples t-test.
that's what I think.
I always guess on these ones, and then if it's wrong, I go back and guess again.
Yeah.
First
Me too.
I just, because I think it's one thing, and then like
It doesn't
never,
work.
it's never the right one, and it's always like always the second one I was thinking.
Mm-hmm.
Yeah. I'm always stuck between two, and I'm like, dang it.
All right. Are you guys ready?
Yeah.
Mm-hmm.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? So this one would be dependent, and it would be the last one.
Yeah.
Yep.
Now you've got to open all the
Yes.
things because now we get to do it.
How great is it?
Is it sad that I'm kind of happy that these kind of questions are back?
Nope, I totally agree.
I'm just gonna be so grateful when this is over. It's the only math class I need to take, and so I'm like,
I thought it was for me too, but I have to take a finance class. But finance has got to be easier than this.
Yeah, I
Yeah,
took
it
that
sh-
class and it definitely was.
Good.
Well, I have to confess, my husband did a lot of the homework for me because I just couldn't. So of course it was
wasn't
easy for
necessarily
me,
easier.
but it wasn't as much work. So
Well, this is
how come we don't have
a
links
lot
to
of
everything?
stuff. How come we don't have what?
Like the oh wow, what are they called? I don't even the quantitative and
they never give it to us. I always have to go into the textbook to grab
I
it.
don't like that. I just would prefer the link to be on the test,
I
and
agree.
then
Put that in the end of the year thing, and I'll put it in mine. And then we'll have at least 3 of us.
yeah, right.
I'll be like, I need it now, okay?
I know it doesn't help us, but
Oh, that's not really what I wanted to do. Okay. There's a possibility I opened everything I needed to, so.
I already had it open because I had done the other thing just before. So that was kind of nice because I looked and they're all the same charts.
Okay, so am I doing it right by doing the first, like the one sample t-test?
Well, so that's the first question, is confidence interval. So it asks which of the 4 confidence intervals listed below, which one's appropriate. And I put confidence interval for mu when sigma is unknown, and that would be that first one. So that's what I think it is the one sample t-test.
Okay.
Oh, no. Yeah, one sample t-test. That's right. And then it's 95% confidence level.
Okay. Confidence.
You might be hungry. Okay, so for the margin of error, did you guys get 1.896?
No.
I got 2.025.
See, so that begs the question again, because I got that if I do it her other way. But I got 13.193 if we do it with the thing that I have in my notes when we did this sigma unknown thing. The notes say it's m equals t times s over square root of n.
Oh, I think I'm doing something wrong then.
And so in my notes, according to my notes, the 13.193 would be the answer. But then later on, she taught us the upper bound minus the lower bound divided by 2, which gives us the 2.025.
Yeah.
Oh, okay. I'm doing something else. Now I know what you guys are talking about. From that video that she shared with us when you posted that question?
Yeah.
Yeah.
Okay.
So you know what? Let's look. Wonder if we could figure out which lesson it's from.
I'm gonna run and get a drink real quick. I'll be right back.
Okay. Okay, so lesson 11 is the one that talks about it.
Okay.
So I'm in lesson 11 because this is the one that talks about the kind of test we're doing. Or one mean sigma unknown. So I'm trying to see what it tells us.
I just don't like that there's so many
Differences?
yeah, like equations to find a margin of error.
I know. I agree.
It's just not right. I probably should have signed up for tutoring in this class.
They should just offer it to everyone.
You're like tutoring night this time, this night.
Everyone needs to be there. Okay, so it says no, that's not what I thought I was looking at. Actually address it, but in my notes I wrote it down. So I'm wondering why.
You're making stuff up now.
Yeah.
You know, I felt so confident too. I was like, I can figure this margin of error.
Yeah, I'm not finding where it says how to do the margin of error for this one. But in my notes, when we were doing it at the time, that's how I wrote that we do it.
Oh.
And I don't know why it would be so different. Huh.
Maybe you can finish it.
So what was the formula you used?
I used M equals T and then times S over N. Well, the square root of N.
Of M or N?
N.
N squared. And what is S again?
The standard deviation.
Okay. So I'm like, I remember this now. I remember seeing this formula.
So is that the one you guys are going to use?
I'm still looking in the book. to see if I can find anything.
So, what's the null hypothesis? Because it changes. The T changes with the null hypothesis. Like if you change it.
I put 0 because we didn't have one.
Okay.
But let me look up again and make sure.
And did you do greater than, less than, not equal to?
I did.
Because I don't think does it really even say?
You know what? Now that I think about it, let me look and make sure that I even have the right stuff still in here. 14.365. Okay, I do.
We are doing the right test, right?
Yeah, we are.
I think I put not equal to because the measurements are recorded. The researcher would like to construct. So what is he trying to find? We don't even know what he's trying to find. So I put 0 and not equal to is what I put.
So cold in this apartment.
See, and they didn't ask that in the questions here. On the test, they didn't ask. What the margin of error is.
And so that way you got 13.189.
I got 13.193.
193. I got 189.
You're talking about for margin of error?
Yeah.
Let me try it again. So I put 4.326 divided by the square root of 20 times, where did I get the 20 from? Was that in there?
Yeah, it's in there.
Okay. Times 13.639. And I get 13.193.
Did you do the square root of 20?
Uh-huh. Let me try it one more time.
Because I'm still getting the same answer.
Yeah, that's what I get.
I'm still getting 13.189.
You know what's interesting is my answer is coming up as the mean.
It is coming up as the mean.
Huh. How
I'm
very
just confused at why. I'm trying to figure out what I'm doing wrong. Let's try it this way. Okay, when I did it that way, I got the 13.139. 193, not 139. But that is interesting that that's the mean.
I'm so confused as to which one we're supposed to use.
I might use the upper. For me, I'm going to use the upper minus the lower divided by 2, I think.
Yeah, I'm wondering about that. Where did I write that in the notes? Because I found out that even though I had written that in the notes. Ooh, you know what? I had written that in the notes as of lesson 11. I had scribbled it out. And then I went back and added them in later. Oh my gosh, who knows what the heck. So 2.025.
Yeah. And then the lower is 11.168.
Yeah.
Is the Nate even on here?
Yeah, sorry, I was getting lunch for my husband. I mean, dinner for my husband. But
No,
yes, I'm listening.
I just, my thing, I don't see the picture, so.
But yeah, I'm going with that 2.02.
Yeah, I'm going to put that too now that I've gone back and looked at this.
Yeah, because like once you mentioned that the way we were figuring it was the mean, like.
But I still have it in my notes that it's that other number, so I wonder how that comes off so wrong. But I have both of those in my notes for that week. That's so weird.
Oh gosh. Okay. Oh sweet, we get to do another one.
We used Hummers. Are you guys ready to do the next one?
Sorry, I'm just waiting for it to load up. Why? Okay.
Yeah, I'm ready. I'm just.
For some reason that was being really
this is
weird, but
This is the paired one, right?
So it's not paired, it's independent. So it's the 2 sample.
Oh, my computer just froze. Hold on.
Awesome.
Yeah, like it's not letting me click anything.
Oh yeah, that's right. It's the two. It's the.
Yeah, so they're independent because they're
Mhm.
not dependent on each other.
Okay, I'm ready now. Sorry.
So can you get it back up?
Yeah, it's good.
We literally had like a drought of all internet stuff in our house today. Nothing was working. I couldn't even call out on my phone.
Oh, really?
Yeah, I needed to go. I was supposed to go to the school interview thingy, school meeting for my son, and I couldn't because I wasn't feeling good and I didn't want to spread the germs, and I could not call the school. So I ended up emailing them, and then they called me because they didn't get the email. And they called me and they're like, "You were supposed to be here." And the worst part is that I've been nagging them because they are well over their amount of days that they're allotted to do this thing. And so I have been on them about getting this done. And then they finally have this meeting for me and I'm like not showing up. I'm sure calling me felt so good. You weren't here. I'm like, well, I tried to call and my phone would not call, so I emailed. And they're like, oh, well, we didn't get the email. All right. Are you guys ready?
Yes.
Mm-hmm.
Okay, a random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, which is the group 1, and Hummers for sale in New York, which is group 2. Create a 95% confidence interval for the true difference of mean listing prices between the 2 cities.
Okay. So my eyes are really tired, and I first thought that said hammers, and I was like, why are we talking about used hammers?
That'd be so awesome. So we're on the 2 sample t-test.
Price.
Oh. Take off my clothes and put pajamas on.
I was like, wow, why are there so many?
I know there's so much information. It's getting me confused.
Paste. Okay. Let's see. Why? Now to know if there's a difference. Okay. It is cold in here. Just saying.
You're cold?
I am freezing. I'm over here.
You are cold.
Yeah.
You are cold. The furnace?
My hands are ice cold over here.
Oh, but you're right by the window. That's probably cool.
Okay. Did we figure out which one of the four?
So we're using the
Oh no, sorry, I meant for the question.
2-sample t-test.
Uh-huh.
So it's the confidence interval for the difference of means using independent samples. Is that what you mean?
Yep, that's what I meant. Okay. Lower. Did you get a negative for the lower?
Yes.
Yeah.
Okay. Negative.
Negative 423.238.
Yes.
Yep. And then the upper is 5417.336.
That's what I got.
Okay.
Another one. I actually don't mind these ones. Like these
I
were
don't mind them. It's just the putting it in.
Yeah, that's definitely
Mhm.
my only complaint. Why? No, don't. Thank you.
So this one's the ANOVA, right? Because it's 3.
Yes.
So 25 was a NOVA, correct?
Yes.
Mhm.
Okay. And the T-score is 7978.
Yep. Although it's an F score.
Yeah, it's that always that throws me off because like I'm looking for the T, but it's
Right.
labeled as
And
an
that's
F.
why I pointed that out, because that's exactly what I did. I was looking for the T and I'm like, it's not there. And I was looking at the bottom left side and it wasn't there.
02. Okay. Ow. 20. Guys, we're like almost there.
I
2
know.
hours later.
So close.
Are you guys on 28?
Yes.
Okay.
So
Do you want me to read it?
yeah, go ahead.
Which of the following best expresses the conclusion of this test? Use a level of significance of A equals 0.05. And the p-value was lower.
So there's sufficient evidence that at least one of the groups has a different mean, right? Because if P is low, we must go. And then we have sufficient evidence that the alternative is true.
Why you gotta be racist, man? Wait, earlier? I took peanut butter and I put it between these cookies. It was so good.
These are the ones that I'm bad at, so
Me too.
Well, because it's confusing. But according to what she said on the video, if P is low, Ho must go. So we rejected Ho. We rejected the null because it was low. So then we have to say we have sufficient evidence that, and then that our alternative hypothesis was that one of them was different than the others. So I think there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
That sounds right.
And I'm almost positive on that one.
okay.
You're really good at those ones, so
The way that these notes are written, that makes sense to me. And those ones, I haven't gotten those ones wrong too many times. So
right, yeah, you're pretty good at those.
those other ones get me, but
Okay, what are we? Oh, didn't we use this one already? For the next one?
yes, we did.
And it was we used the paired sample, right?
Yes, because that didn't make sense to me the first time that it was paired. Because the flights, it wasn't the flight that was the same, it was the low fare that was the same.
So
But it is, if I remember right from when I got it wrong, it is dependent, and that worked for all the answers in the book review.
So it's the dependent samples test?
I do think it's the dependent, yeah.
Okay.
Which is the paired, correct?
Right.
Yep. Okay. Oh, I should probably open the file would give me my information.
25.
Mhm.
I don't like either one. So, that's 3, 2, 1, got it. Okay, that equals 39 again. 28. Math right now.
I hope we do good on this because I don't want to have to redo it because I'm going to be traveling.
I am with you on that.
I'm already gonna get to Utah at it's so late. And these people I'm staying with are gonna wake me up super early. I forget. Okay, so does it say which one they want first?
What do you mean?
Oh,
Oh,
do 14
no.
days
Yeah,
minus.
so it's post minus pre, and post is the 14 days. So 14 days.
Okay,
would
well,
be-
it does tell us at the end. It says 14 days minus 90 days for the analysis.
Ah, there you go.
But thanks for. You're like, I got you. I got this.
Where I'm like super white. Like this one I turned out nice, but
For the test statistic, do y'all have 1.685?
Yeah.
Okay.
Oh, I forgot to do that. That would be helpful. No.
no, it's just darn 14-year-old from my home state that texts me all the time. Right? You have a nice word, but
Can you help me put away your...
Oh.
Never mind.
I'm glad you appreciate my
Can I see that?
And for the p-value, you guys got 0.096.
Yep.
Oh, sorry. I'm still trying to input this.
Oh.
info. My computer's just very slow today. Okay. I don't even know what they're wanting.
Mhm.
this piece from
The test statistic is you got 1.636 for the test statistic.
1.685.
1.685. Mine says 1.636. Oh wait, hold on. What's
one word or no?
The
It's
null
point
is 0
90.
and the confidence level is 90.
is 90?
And it's
And
not equal to.
not equal to. Is there a hypothesis or null hypothesis?
No. So we put 0.
I still got 1.636.
Even when you changed it to 90%?
Yeah.
Rent us peace for like 30.
And you have it as not equal to?
Yep. So I wonder if I messed up a. All right, I'll try it one more time. I don't. That's so weird. Okay, 14. Copy. Paste.
Wow, I can pour in some milk. Oh, no.
Yeah, I still get 1.636. So I'm wondering,
What do you get for your p-value?
1.105.
Are you in the paired test?
Yeah.
And you put the 14 days in the A column?
Yep.
That's so strange.
Yeah, it's
The voice, yeah.
so weird. Is the p-value different too?
Yeah. You both got 0.096.
What is different?
I just see if it stays till tomorrow. Because like sometimes it does.
It's so weird.
Yeah, I don't know what would be different.
So I'm double checking. Yeah, I have the 14 in A and 90 in B. Confidence level is 90. Zero hypothesis not equal to.
I have no idea how we would both get different answers than you.
Yeah. See, this is why I hate this.
I thought you liked it like 5 minutes ago.
I did like it 5 minutes ago, but now I don't like it because we have different answers. I'll do it one more time, but I'm like,
I'm wondering if one of the calculations in the the differences section is off because I had to refill in 5 of mine. For some reason, they were just erased.
yeah, I went in on the, I added the third column in on the direct flight and I just copied and pasted the whole thing. I don't know.
Hmm.
No.
Trying it one more time. Yeah, because you guys get the same answer, right?
Yeah.
Yeah.
I still get 636.
Gonna look on the. So that's not even a multiple choice answer on the practice one. So I'm gonna say go with our answer.
Okay, but I'm still trying to figure out, like,
Why yours is wrong.
well, yeah, like why it's giving me a different answer, because I'll need it.
Yeah. And that was really rude the way I said that, why yours was wrong. But why yours is coming up different.
Yeah. I don't know. Okay, so yeah, just let me know what you guys got, I guess.
We got 1.685.
685.
And then for the p-value, we got 0.096. 0.096.
Okay. Last question.
So our p is low.
So we reject it, right?
We do reject it.
So it's insufficient, right?
No. So
No.
it's
That's what always confuses me.
sufficient evidence. Yeah. So we have sufficient evidence that the alternative is true. So I think it's the second one. There is sufficient evidence to conclude that there is a difference in the mean cost of tickets.
Okay.
Do you guys want me to submit first?
Sure. Yeah, I was brave last time.
Yeah. I tried to be.
I know, but I was like, no, I already had it.
Okay, it's coming up and then I'll tell you. Okay, we missed question 5.
Question 5.
So I think it's the 99% confidence interval, even though I got myself totally confused on that.
See, honestly, that's what I thought, but I don't know. I second guessed myself.
And then we got 12 wrong.
12.
Oh, well, I got 12 wrong. I think that's the one we all agreed to put different answers. I put the 60 GPAs and all.
I got the third one, so I don't know. Who knows who's right?
Right. Well, it's not the last answer.
Okay, I didn't choose that one, so.
Okay.
Under a rock. And like broccoli nachos. Think about it. Ooh.
Sorry, I'm going slow so I don't miss anything.
Gross. I don't know how
Oh,
you just
no
did it.
worries.
Oh, I can see it being good.
It looks like everything else so far is good.
That would be good. But lettuce and broccoli.
Yeah, just those two.
Okay.
Or you could just broccoli. I like to do rice and chips and cheese.
Show us a minute then.
It's wrong. Number 5 is wrong again.
What did you put for 5?
Right now. You gotta put a bunch of
The
sriracha.
99%.
Okay, so it's neither of those.
All right, hold on. I haven't submitted yet, so let's see.
Lucky.
Number 5. Where is number 5? Okay.
They have cake with the same fat in the middle.
I got 12 right though.
So what?
So that's good to know. It's the third one, not the last. So number 5 is
okay.
not the top one.
So then it's the last one?
I mean, it can't be that. I mean, I'm not positive, but lower than higher in number of people that you test can't be right. So it's got to be the lowest. It's got to be the last one.
I will click the last one. Okay, and then 12, I selected something different. So 12 is the third one?
Uh-huh.
That's so weird. They threw the bell shaped in there and it really threw me off.
Yep.
Okay. Okay.
Because it's not like statistics is hard enough.
Right? And there's 72 equations to find one thing. Let's see. I'm going to submit it. Five is the last one.
Yay. At least we have an idea now.
So we don't submit our video?
Oh, I got another one wrong. I got 26 wrong. I might have typed it in wrong.
7.978.
Huh?
It's 7.978.
Yep, I typed it in wrong. I put 798. Okay, well, that's whatever.
I know, I'm trying to decide if I want to go back and type all these answers in again. There's that part of me that's going, you better do it, because if you don't do it, then the test is going to make you look bad, and then there's that other part of me that's like, who cares?
There's part of me was like, that's the only one I got wrong, and I still have to pack and travel to Utah, so
Yeah.
I will not be doing that.
If I were you, I wouldn't do it.
Hey, there's no place for me to post the video, so we don't have to post it this week?
I wonder, since it's the review, I don't know. That's really weird.
I thought they're still...
Actually, I vaguely remember having that happen one other time. Was that in this class? But I wondered the same thing.
Yeah, like it's not even one of the things that we have, like, you know, like to get the check mark.
Yeah.
It's not even on here.
Yeah. That's what I saw. I was like, what?
Yeah, I don't know. So I think we were just, I don't know. That's weird. Like, if we meet together, like, and we always turn it in, then we should just turn it in. But all right.
I thought they said there was no homework, just to review.
Yeah.
Alright.
Okay.
Well,
Well, we have proof just in case, so.